Okay, 7.4, day 1. So warning, this section requires very strong algebra skills and attention to detail. Please take it slow and watch your calculation. You're now warned. So if you make one small mistake, it's almost impossible to solve. So you cannot make any mistake. Please be careful. All right, let's go ahead and review Algebra 2 stuff. So how do you combine these into one fraction? How do you combine these two into one fraction?
Oh, times the x plus 3 for that for the x minus 4 side.
Oh.
Well, how do you say it's called, like, there's a word for it, but.
So we need to have.
Yeah, sure.
Okay, so in order to combine them into the same fraction, you need a common denominator or least common denominator, which is going to be what? Everybody? Okay, x minus 4, x plus 3. So that means on this left-hand side, what do we need to multiply by? Yes, x plus 3, top and bottom. And then what do I need to do on the right? X minus 4, yes. Okay, we're going to do this really quickly. So we're going to distribute and then combine the numerator into one big numerator. Since you guys are in pre-calc, let's just do that really fast. So you're going to distribute, and they're all going to combine together into one big numerator in the top. So 3x plus 9 plus 2x minus 8, that's the entire numerator, over a common denominator, x plus 3, x minus 4. And then we try to combine like terms. That's going to be 5x plus 1 over x plus 3, x minus 4. Good? So Algebra 2 review. This section, however, is the other way around. So now that you're in pre-calc, what's going to happen is I'm going to give you this final product. You need to decompose it into those two fractions. So now you know how to combine. We're going to take it apart. Okay, so this is called partial fraction. Partial, remember, means part. So it's not the whole. The whole one is one big fraction. We're going to split it into partial fractions. So one fraction, one fraction, one fraction. And so this is called partial fraction. And what you're doing is you're decomposing. You're kind of breaking it down. So it's called decomposition. So whenever someone says, we're doing partial fraction decomposition, that's what you're doing. You're taking one fraction and you're taking it apart into one fraction, one fraction, one fraction, and so on. Okay, now how do you do that? That's going to be a little tricky. So there are some steps. First, step number 1. You have to check that whatever you're trying to decompose, the numerator, the degree in the numerator is less than the degree of the denominator. The degree of the numerator has to be less than the degree of the denominator. It cannot even be the same degree. It has to be less than. If it is the same or higher, we're going to talk about it tomorrow, what we're going to do. Step 2, you need to factor the denominator. Definitely always factor the denominator. All right. So I'm going to show you how to do this one, this particular one we just combined together. We're going to split it apart into the original problem. And that is going to be the next page. So we're going to go through steps 3, 4, and 5 later because that's for more complicated problems. But let me just show you how to do one. All right, step 3. So what happens if it's actually not as... it's not just one factor at a time. So what if you get something like this? 3x over x plus 1 squared. Okay, x plus 1 squared. Whenever you have a factor that is repeating, you have to write it a little bit differently. So we know that it's definitely going to be x plus 1. But it is actually x plus 1 squared. So therefore, anytime you have a factor that's repeating, you have to write it again, but 1 power higher. Does that make sense? So This is an x plus 1 factor that repeats itself. So when it repeats itself, you start with the lowest power, lowest degree, which is just x plus 1, and you raise by 1 power until it gets to whatever that degree is, which it says is squared. Okay, so for example, let's do this other one. Let's say that it is x plus 3 to the 4th. So this is a little extreme. All right, okay, so this is x plus 3 to the 4th. So what factor is being repeated? Yes, x plus 3. So we're going to start with x plus 3. And then we're going to do 1 degree higher at a time. So the next one is x plus 3 squared. The next one after that, yes, cubed. And then the last one is x plus 3 to the 4th. Anytime you have a factor that is repeated, you start at the lowest and then one higher until you get to the highest power. Are you guys okay? Repeated factors. Now, what goes on the actual numerator? Depends on the denominator. So what is the degree of the denominator? 1. So what's 1 degree less? 0. So what goes on the numerator? A. Okay. This next one is a little trickier. What is the degree here? 2. However, we don't care about repeated factors. We only care about what it was before it was repeated. So what was it before it was repeated? How many degree? 1. So then what would be 1 degree less? 0. So what goes on the numerator? B. Okay, this gets people every time because they're looking at 2 and they said it's degree of 2. No, it's not. It's a repeated factor. If it's repeated, you look at what was repeated, the degree of that only. Okay? Let's try another one. X plus 3 cubed. What is the degree that we actually have to look at? Is it 1, 2, or 3? 1 degree. This is 1 degree. We don't care about this cube. Okay, only whatever is being repeated. Okay, we don't care about the power. Okay? Okay, 1 degree. So 1 degree less is 0, so C. C goes on there. Okay, what goes on the last one? D. Are you guys okay? Okay, so let's come back to this one. So what goes on the coefficients then? A and B. All right, next case. When you have something like this where, remember I said you have to factor the denominator. Now, if you get to this term, x squared plus 1, is that factorable? No. If you try to factor, you're going to get imaginary numbers. So we're going to say that's not factorable. When you get to non-factorable, non-linear factors, you're going to leave it as is. So essentially in the denominator, there are only 2 factors, x and x squared plus 1. So you're going to write x squared plus 1, because x squared plus 1 you cannot factor. All right, in the first one, what goes on the numerator? A. Are you guys with me? Okay, I know here people get it, but people who are not answering, are you? No, you're not getting it. Okay, so every factor in the denominator gets its own partial fraction. If it's a repeated factor, that means it has a degree, like an exponent. You have to repeat it until it gets to that number of degrees. Once you set up the partial fraction, you look at the degree of the denominator. The numerator is always going to be 1 degree less. Okay, so what is the what do you write in the numerator for this first fraction? A, yes. Okay, and then second one, what is the degree of the denominator? 2. What's 1 degree less? 1. So what goes in the numerator? This is a little tricky. Huh? X, yeah, something x. Because 1 degree less is x. Yes? But we can't just write an x. We have to write bx. because we are trying to guess what could be there. So B is my placeholder. However, I have to add a C. So we have to add until it gets to 0 degrees.
Oh, wait, where did the x come from again?
1 degree less than x squared is x.
X.
And then I put a placeholder coefficient because I don't know what it could be, so I put something there so I can guess.
And then the last one to 0 will be C.
Yes.
Oh.
Okay, so for example, let's do an extreme example. Let's do really extreme. X to the 4th plus 3x plus 1. I'm going to assume that is not factorable. It's probably not factorable. What is the degree of the denominator? 4. What's 1 degree less? 3. So what goes in the numerator? A x
plus
cubed
oh, okay.
plus
bx
bx
plus c.
squared.
Oh, squared. Plus c.
Uh-huh.
I keep missing.
Correct. Yes, so that's how you do it. Yes.
Where do you get the C from on the first
Oh, you have to keep that.
You have to so you start with 1 degree less, and then you add a term that's 1 degree less than what it was.
Oh, okay.
Okay? All right, let's practice. So let's go to, okay, so for these, I don't want you to solve, I just want you to write it out. Okay, let's do one together. Let me give you the easy one. Let's do the hardest one together.
Okay. You already know where you're
All right, this one here. Let's do this one. Second to the last. Are the denominators factorable? No. No, that's it. We can't factor anymore. So let's write out our partial fraction. Remember, each factor gets their own fraction. Okay, now what goes in the numerator is going to be 1 degree less. So in the first fraction, the denominator is x squared plus 1. What's 1 degree less? Ax. Okay, so you said 1 degree less, and you said was ax. And then?
plus b.
Plus b. We have to add all the way to 0 degree. Okay, what about this next one? That is...
Oh, wait, no.
Yes, we start at c. Cx plus d. All right, Eunice has a suspicious look. Why c?
Because we already used up the b.
Yes, we already used up a and b. You
Oh,
can't
maybe
repeat
different,
the
yeah.
letters. If you repeat, you're saying they're the same.
Okay. So they're just placeholders.
They're just placeholders. It could be 0 at the end. But you got to put it there so that you can solve it. All right. Okay. All right. So let's have you guys try all of them. You are not solving them. You are not solving them. Just write the placeholders. I want to make sure that you can write it out before we solve.
This is the point of this
Hmm?
Is this lesson, do we solve it then?
Yes. After this, we're going to solve everything. Okay, the first one is factorable. We're going to get x minus 4 and x plus 1. So that's just a and b. The second one is also factorable. That's going to be 2x minus 3 and 2x plus 3. So that's also a and b. Okay, the next one is a repeated factor. So we start at the lowest degree, so x minus 2, and it goes up until we get to the highest degree, which is x minus 2 squared. That is a and b. The third one, that's a repeated factor 3 times. Okay, A, B, C. Okay, the last one, you can factor. You have to remember in Algebra 2, we did it by grouping. So take out x squared, that's x plus 2, take out 9, that's x plus 2. Make sure you put a plus sign in between those two terms. Then you take out the greatest common factor between both of them, which is actually x plus 2. The leftover is x squared plus 9. Okay, so that's going to be x plus 2, x squared plus 9. This is going to be a, this is bx plus c, because x squared plus 9 is not factorable.
Wait, what if I put x squared plus 9 first?
Yeah, it doesn't really matter.
Okay,
Once you
that's
solve,
then it's gonna be-
yeah, it's going to be the same numbers. Let me give you one kind of trick question.
Okay.
X to the 5th. How would you write your partial fraction? I don't really care what goes on the top, but how would you write your partial fraction? So work with your partner. How would you do this? Okay, so how many people wrote something like this?
I was thinking that, but I feel like it's fine.
How many people wrote that? Okay, good. That is incorrect.
I knew it.
That is incorrect. What did you guys do instead then?
We did like over x plus over x plus over x, like 5.
Like this?
Yeah.
5 times?
Yeah.
Yeah.
And then powers.
Yeah.
And then powers.
Yeah.
Okay.
Wait, that makes no sense. Does it? Does it make
How many people did this?
That's right. That might be.
Okay, that is correct.
Oh, that's right.
Then what goes on the top? Okay, I thought everyone who can get to this will get the right answer, and then I realized it's not true. They still missed the last step. So what's... Okay, so how many people put something like this?
Yes. That makes
Yes?
sense. Yes. That's
That
right.
is incorrect.
Wait, what?
That is
Oh,
incorrect.
Because it doesn't.
The correct answer is this.
Oh, you're right.
It's x repeated.
Okay.
X is the repeated term. So like I said, this is like one of the most commonly missed thing that we don't see x as a repeated thing. So please be careful, that's a linear term repeated 5 times. All right, now we are ready to solve a real problem.
We're solving it now.
We're now solving. All right, next 2 pages later, sorry. Page 17. Okay, so this is the question that we just did where we combined it together and we got that fraction. So to start this, first step, check that the degree of the numerator is less than the degree of the denominator. Is that true? Yes. Okay. Second step, we need to factor the denominator. All right, so we're going to factor the denominator. So that's going to be x minus 4. X plus 3. All right, so somehow I need to decompose it into some fractions added together. Now, if we are going to add the fractions together, they have to eventually combine together to have a denominator of this least common denominator, correct? That means each denominator will probably be one factor by itself. Does that make sense? Okay, so a good guess is that each factor will have its own fraction. Yes? Okay, so each factor has its own fraction. So remember, what we're doing right now is guessing. We don't know, so we're making our best guess. The next thing is asking yourself, what number will go on here? We don't know. So what we're going to do is make educated guesses. So this is how the game works. For each partial fraction, you look at the degree of the denominator. What is the degree of the denominator? 1. Okay. The numerator is always going to be 1 degree less. What is 1 degree less than the denominator? What degree is that? 0. What is 0 degree? Huh? You guys have to speak up. I can't. 1, a number, right? So what we're going to do here is write A. Oops. We're going to write a placeholder, A. We don't know what that number is, but it's going to be a number. So we're going to write A. All right, next one. X plus 3, this fraction, x plus 3. What is the degree of the denominator? 1. What's 1 degree less? 0. So then what goes here? B. Another number. But we are not going to use A again. If you use A again, you're saying they're the same number. They might not be the same number, therefore you have to put a different variable. All right, now we need to solve for A and B. All right, what do we need to do to solve for A and B? Any thoughts? 2 equal to the left.
Yes.
Mm-hmm.
Okay.
Yeah, but how?
Oh. wait, you're saying,
We need to solve for A and B. We're not solving for X.
oh, then times the 6 minus 4 and plus 3 to cancel that on the other side.
Yes, we have to multiply by the least common denominator. We're trying to get rid of all the fractions in order to solve this. Okay, so x minus 4, x plus 3, and we need to distribute. Okay, so I need everyone to stay with me and stay alert. Okay, so we're multiplying everything by the least common denominator. So if I multiply this to this term on the left, what is left over? 5x plus 1. Everything in the denominator cancels, right? So 5x plus 1. This one. This least common denominator multiplied by this term that has a, what's going to cancel?
The
X minus 4, what's going to be left over?
x plus 3, so it will be ax plus
A and then x plus 3.
oh.
Okay. Same thing. Least common denominator multiplied by this last term, what's going to cancel?
The
X plus 3, what's left over? B times x minus 4, correct. Okay, now remember again, we are solving for A and B, not x. We don't care about x. We are trying to decompose. It's going to have x in there. So the left-hand side has to equal the right-hand side. So what we're going to do is distribute. Okay, again, left-hand side equals to right-hand side. You can see that in this equation, we have 5x, so basically something with x, plus 1, so something with a constant, equals to blah. On this right-hand side, we have something with x's, something with just a number. Remember, A and B are just numbers. So what I'm going to do is I'm going to kind of try to combine like terms. So I'm going to put all the x's together. And I'm going to put the ones that don't have x because they are just constants. I'm going to put them together. Okay, so I just reordered everything. Put all the x's together, numbers together. Then what I'm going to do is I'm going to kind of group them together. Ax plus bx. Huh?
I was thinking of
Ax plus bx, what I'm going to do is I'm going to take out the x. I'm going to factor out the x. But when I factor out the x, usually we factor on the left-hand side. This time I'm going to put it on the right-hand side because I'm going to try to do a matching game. So a plus b times x plus 3a minus 4b. And that whole thing has to equal 5x plus 1. Okay, now what's going to happen is you can see on the right-hand side there's coefficient x plus constant. On the left, you have coefficient x plus constant. Therefore, 5 must equal a plus b. And then 1 must equal 3x minus 4b. Does that make sense?
yes.
Okay, so this is very, very important in math where when you're trying to solve for something, just ignore that x. Left-hand side must equal right-hand side. So you're trying to look for things that match. Okay, so then 5 is equal to a plus b. 1 is equal to 3a minus 4b. The question now is, how do I solve for a and b? How do I solve for a and b?
Oh, don't you like, can you like, what's it called?
Substitution?
Yeah, substitution.
Yes, you can use substitution. What else can you do?
Or you can do the elimination.
Elimination. Now that we're on chapter 7, chapter
You
7,
want us to use matrix?
yes, you can use matrix. Now, for this one, you don't need matrix because this is very, very easy. But eventually, we're going to have like 4 variables, A, B, C, D. You have to use matrix because it's just not impossible to solve by hand. All right, so I'm going to show you how to do it by matrix. Usually, you don't see this in matrix kind of form, right? Usually, you put variables on the left and number on the right. Okay, how do I do this by matrix? We learned 2 ways with matrix. What were the 2 ways? REF is kind of better. Yeah, REF. So that's one way. What's the other way? REF is very similar.
Inverse.
Yes, inverse matrix. So I'm going to set both up for you, and you can decide which one you want to do. Okay, if you do RREF, you are doing 1, 1, 5, 3, negative 4, 1, and you're trying to get to 1, 0, 0, 1. If you do inverse matrix, you go 1, 1, 3, negative 4. That's multiplied by A and B, which is equal to 5, 1. Either way, you should get the same answer, and the answer should be 3, 2, right? Because that's the fractions we had in the beginning. Okay, so you're going to try solving this by matrix. Of course, this is much easier if you just do substitution, but I want you to try it with matrix. Try to find A and B. Once you find A and B, you need to write the whole fraction again, the partial fraction. So from the calculator, whichever matrix you get, you use, you should get 3 and 2. Remember, 3, 2 is not the answer. The question is asking for partial fraction. So you need to plug A and B back. So that's going to give you 3 over x minus 4 plus 2 over x plus 3. So this is the answer. Okay, let's have you guys try one on your own.
This feels like a
Next. This one. Find a partial fraction decomposition of, and first you check. Is the numerator degree less than the denominator? Yes. Next thing, factor. Factor and then set up your partial fraction. What does this denominator become? X times x plus 2. Okay, so what are my partial fractions, the denominator?
A over x plus b over x plus 2.
Okay, go ahead and solve for A and B and then put it back into the partial fraction. Let me know when you have your answer. It's going to be 1 over 2x minus 1 over 2 times x plus 2. You don't want to leave it as 1/2 over x plus negative 1/2 over x plus 2. That's very, very awkward. You also don't want to put 0.5. You don't ever put decimals with fraction. It's just very awkward. So please leave it like this.
Wait, do we times the 2 with it or just leave it as 2 times 2?
You can do both. You can distribute it or not. Okay, so let's go back to the first page that we were working on. Page, sorry. All right, this one. Find a partial fraction decomposition. I think this is page 17. Okay, so this part, factor. Do you need me to help you factor or you can factor? No response. I think that means you can factor.
You can take out an x.
Okay, you can take out an x. X squared minus 4, x plus 4.
And wait.
X minus 2 squared. That means we have a repeated factor. All right, go ahead and set it up. Solve it. It is going to be a little long. You might want to use a calculator to do your matrix. Okay, so this is going to be a over x plus b over x minus 2 plus c over x minus 2 squared. To solve this, you need to multiply by the least common denominator. This is just very long, but it is solvable. So least common denominator definitely has to be just that denominator. So on the left, everything cancels. So negative x squared plus 2x plus 4 equals, if you distribute it to the a over x term, what cancels? The x. So we have leftover with, correct. Okay, plus, in the b term, bx, x minus 2. Okay, and then the c term, cx. Okay, this is just going to be long because now you need to FOIL that x minus 2 squared. Please don't distribute. And then you need to make all the ones that look the same together. Okay, x minus 2 squared is x squared minus 4x plus 4. This you need to FOIL. Bx squared minus 2bx. This is why I said you can't make mistakes, because if you do, you start solving your coefficients and they start becoming crazy decimals that you can't figure out. All right, ax squared minus 4ax plus 4a plus bx squared minus 2bx plus cx. All right, the ones that look the same have to be combined together into one big coefficient and then make it equal to the left-hand side. A is 1, B is negative 2, C is 2. So this is 1 over x minus 2 over x minus 2 plus 2 over x minus 2 squared. All right, tomorrow we're going to continue on this.
And I didn't have time to do the circle sign.
Yeah.
Well, you had to finish. You had
I like this one.
I need to give you.
Because I guess I'm
no today. Send me a picture.
After-
so useless time.
Yeah, send me a picture sometime today.
Oh, send me.
Yeah.
It's my only thing I'm good at. Oh, but then you have to use matrices. So.
Okay, hold on. It just smells, so I don't want to leave the door open.